In example 1, we want to find the solution to the system 5x minus 4y is equal to 28, which I'm going to denote as my blue equation, and negative 2x plus 3y is equal to negative 14, which I will denote as my red equation. To solve this system, I'm going to set up a 3-column approach, and we're going to talk about using the elimination method whenever one of the variables is not obvious for us to eliminate. What we mean by that is if we look at the x's, there's really not a number that 5 and negative 2 could meet up at. I can't multiply negative 2 by anything in order for it to equal a 5. Similarly, I cannot eliminate the y's very easily because there's no number that I can multiply 3 by in order to get a 4. And so what we will have to do here is multiply both equations by a constant in order to eliminate one of the variables. Now, you have a choice as to which variable you want to eliminate. And so if we look at the x's, 5 and negative 2, we need to find a number that those two numbers could meet up at and be opposite coefficients, meaning that they're the same number but opposite signs. And so if you think about 5 and negative 2, the first number that they would be able to meet up at would be a 10, because think about the multiples of 5. You have 5, 10, 15, 20, etc. And for 2, you have 2, 4, 6, 8, 10, etc. And so the first number that the x's would be able to meet up at would be 10. And so that is the approach that I'm going to use in order to have these x's eliminate. And so if I look at the first equation, what am I going to have to multiply 5 by in order to get a 10? And the answer is a 2. And so I'm going to multiply my blue equation by a 2 so that we can eliminate the x's. And so 2 multiplied by my blue equation will give me 2 times 5x, which is 10x, 2 times negative 4y, which will be negative 8y, is equal to 2 times 28, which will be 56. Once I do that, I will copy and paste that equation into the second column. 10x minus 8y is equal to 56. Then, looking at my second equation, what I want to do is get this to be a negative 10 so that it will have the opposite coefficient of the 10 right here. And so what do I need to multiply negative 2 by in order to get negative 10? That would be a 5. And so I'm going to multiply my red equation by a 5 so that my x coefficients will meet up at 10 and negative 10. Distributing here is going to give me 5 times negative 2x, which will be negative 10x. 5 times 3y, which will be positive 15y, is equal to 5 times negative 14, which will be negative 70. I can then copy and paste that equation into the second column. Negative 10x plus 15y is equal to negative 70. What you'll notice now is that if we add these two equations in the second column, our x's are going to eliminate. Notice that we have a positive 10x and a negative 10x, and when we add these together, those are going to cancel out. For my y's, I have negative 8 plus a 15, which is going to be 7y, is equal to 56 plus negative 70, which will be negative 14. Notice that in order to solve for y, we would just divide both sides by 7, and so y is going to equal to negative 2. That is half of my solution, and in order to find the other half, we need to find x. What we're going to do in our third column is choose either of our two original equations and substitute in y equals to negative 2 and solve for x. And so if we start with our blue equation, the original blue equation from the problem, we will have 5x minus 4 times y, but instead of y, we will replace y with negative 2 or substitute in negative 2 for y, and then start solving for x. 5x, negative 4 times negative 2 is going to be positive 8. is equal to 28. In order to solve this equation for x, we will subtract 8 on both sides. That will give us 5x is equal to 20, and then divide both sides by 5 so that we get x is equal to 4. Therefore, the solution to this system of equations will be the ordered pair 4, -2.